Hello and welcome to the Savvy Safety Sisters Partner and Prevention Podcast. I'm your host, Carrie Pasquarello of Global Secure Resources. Now, one of the most powerful ways we can reduce risks and prevent harm is by sharing real stories from around the world. Stories that educate, inspire, and sometimes even save lives. Now, our mission is simple and powerful: to turn awareness into everyday action to help you stay informed and prepared to protect what matters most. We aim to empower our audience with education and advocacy through expert insights and guidance with voices that need to be heard. Now, many of you know that I've covered a lot of stories about CADASIL. Now, CADASIL is a genetic neurological condition that affects the small blood vessels in the brain and often leads to strokes and unfortunately is often misdiagnosed or underdiagnosed. Now, I've interviewed patients, families, and many in the medical field, but today's guest is making groundbreaking advancements with CADASIL and bringing hope to so many people around the world. Now, I'm honored to introduce Dr. Joe Arboleda-Velasquez. Now, he's an associate professor at Harvard Medical School and a leading researcher at the Shepard's Eye Research Institute of Mass Eye and Ear. As both a physician and a scientist, his work focuses on the small vessel diseases like CADASIL and uncovering protective mechanisms in Alzheimer's disease. Now, he's internationally recognized for his groundbreaking discoveries in genetics and vascular biology. His research is helping shape the future of how we understand, potentially prevent neurodegenerative diseases. So please join me in welcoming Dr. Arboleda-Velasquez. Thank you so much for coming.
Thank you, Carrie. Very excited to be here with you.
Oh, that's fantastic. So tell us a little bit about yourself and when did you first become interested in CADASIL?
Oh my God, it has been a long time. I was a medical student. I am originally from Colombia, and I was in medical school, wanting to get more involved in research. And my mentor there, Dr. Francisco Lopera, told me about some families that he had, and he suspected they had CADASIL. So we are talking now maybe 1997, 1998. So it's a very long time ago. And that really became my passion since I started working with these families. At the beginning, it was just kind of like seeing the patients, making a family pedigrees, and having them come for us to do clinical exams or taking an MRI, collecting blood samples so that later we could do genetics. So it has been a long time, and I made the decision to really focus on CADASIL and finding a cure for it. I was very young, and I wanted some ideals and something to do with my life, and I chose CADASIL as my focus.
Wow, that's really amazing. Now, CADASIL is often misdiagnosed as MS, migraines, Parkinson's, and early onset dementia. Why is it so hard to recognize and what should clinicians be looking for?
I think the main problem with misdiagnosis is that there are just not that many patients that have CADASIL as there are for let's say MS. So the clinician is very aware of multiple sclerosis. They are more aware of Parkinson's also because it's more obvious with the movement, the abnormal movements that the patients have. And the clinicians don't really think too much about CADASIL. So when a patient comes in and they look at the MRI and their brain and some symptoms, they often misdiagnose it. They are like, well, it's probably MS or it's probably something else. So I think I would say mostly lack of awareness, and also the requirement for diagnosis. We need to do a genetic test. For MS, you don't have to do a genetic test. You just do MRI. For CADASIL, for proper diagnosis, we have to take a blood sample, look at the DNA, and see if the person has a mutation in a gene called Notch3.
Right.
So all these steps, I would say those are the two factors. One is that is not as common, and the other one that it requires genetics. So
Right.
those two barriers limit number of patients that we get to diagnose proper.
So then, as we're talking about, that type of situation where there aren't that many patients, roughly how many people are affected?
Well, now we have to distinguish how many people have like a variation in the gene NOTCH3 and how many people actually have symptoms. That could be migraine or a stroke or cognitive decline and dementia. So the number of people that have these variations in the gene called NOTCH3 could be quite a few. It could be many, they could be quite common. Maybe in 1,000 individuals, you can find like several of them. But now, how many of them will actually get the strokes, the dementia? A lot less. So you kind of have to like identify maybe 100,000 people, and in them, a few of them will have it. So in the United States, I think we will have probably less than 200,000 people with CADASIL. But that is a lot of people for the people that have it. And when someone has CADASIL, it's not just the patient that suffers, also their family. So how many people are impacted by CADASIL? I would say that have the disease, maybe less than 200,000 that are impacted by it. I think we have to get it up to like 500,000 or 1,000,000 people. Because if you have a friend with CADASIL, or if you have a cousin with CADASIL, you are impacted by it. You care about these people and you want it to do well.
Sure, absolutely. Now, I've been to your lab and I've had that opportunity to hold the therapeutic drug that you're working on. That was so amazing. Can you tell our audience more about what's actually going on with the molecular level of CADASIL and how does the therapeutic drug intervene in that process? Because that's amazing what you're doing up at
I
the
know it's great to have you. It's great that you were in the lab and you got the chance, because sometimes we talk about therapies and is in the abstract. So I tell people in my lab, no, you have to get it out of the freezer. They have to hold it in their hands. And this is for me is a dream come true. I've been chasing this for almost 30 years, as I told you, and I have gone in different directions, trying to understand the biology. The biology of CADASIL in a way is simple. The arteries, the blood vessels in the brain really degenerate as if they were like very, very old, but it happens in young people. And they degenerate and they burst and they don't function well. So they don't feed the brain. Uh, and, I try to understand that biology. We made mouse models. My laboratory over the years, or, even when I was a graduate student, I got my PhD from Harvard Medical School. After I finished my training in Colombia, I came to Harvard, I got my PhD, I dedicated my PhD research to focus on CADASIL, and then in the postdoc all throughout. I've been working on this in different capacities, and we made breakthroughs. Some of those breakthroughs were, okay, let's make animal models. We need to make animal models for CADASIL. Let's try to understand how the vessels degenerate and why. In CADASIL, we have these deposits in the blood vessels called granular osmophilic deposits. Let's characterize them. I was one of the first ones to characterize the deposits, make animal models for CADASIL, study the biology, determine the role of like signaling NOTCH3 is a receptor in the cell. We need to know how it related to the pathology. And we did all that. And over time, I felt like, okay, I think I have a good understanding. Let's make therapies. And for some time, I was focused on like an antibody therapy for CADASIL. I think it has some potential, but antibodies are, very expensive to make and difficult to administer. People have to go every 2 weeks or a month to get an infusion. So I kept on trying and I kept on looking until we identify this small molecule. This small molecule, meaning is something that you can put into a pill. So this small molecule is called Rho247429. It's an amazing drug. It was developed a long time ago for a different indication back in the 90s. People were trying to find drugs for people with HIV, and they work on this drug. And it didn't work that well for people with HIV. It didn't help them, but it was found to be safe. So much later, in 2012, NIH found out that this molecule that had been used in people with HIV was very active at inhibiting a protein called RANX1. RANX1 is a protein that regulates the expression of genes. We've been talking about genes, and there are some genes that regulate others. They are like master regulators. You can think of them as the ones that tell other genes what to do. So RANX1 is one of those, and it's very powerful. And they found that this molecule that had been tested in people with HIV and didn't work there, but it was found to be safe, turned out to be an inhibitor of RANX1. And in my laboratory, we have been working on RANX1 because, for more than 10 years, we've been working on this protein RANX1, and we found out that it's very important for the vessels, for the blood vessels of the eye, the blood vessels of the brain. And we were working in different systems. And about a couple of years ago, we decided to test, I kind of had like a moment of realization that maybe RANX1 was potentially also important for CADASIL. And very quickly, we tested the drug, the RO24. We tested it we can call it, it's called RO247429. So I came up with a name for it. It's called Rory. Rory is kind of like RO24 and then RANX1 inhibitor, Rory. I think let's keep talking about it as Rory. So this drug, we tested in some of those animal models that I had developed for CADASIL, and the results were spectacular. We found out that very quickly, even in animals that had established pathology, the drug was able to promote repair of the vessels and diminish, I was telling you how the vessels degenerate. So the degeneration of the arteries was stopped. And sometimes when the blood vessels degenerate, they also burst and they leak. So we found diminished evidence of leakage. And we got very excited. The results were really very unexpected and also quite robust. So the moment as a scientist, when you find that, you kind of have to, you need to determine that there was probably not a mistake, see if it works in a different model. And we did that. So we tested now animal models that have NOTCH3 mutations. We have tested 3. One of those animals don't even have NOTCH3, the gene that is linked to CADASIL. And 2 other models, they have specific mutations that we found in families with CADASIL. So we have tested 2 different CADASIL mutations. And I wanna, for the first time, announce that we also tested a different mouse model. Guess who also gets vascular degeneration in their brain? People with Alzheimer's disease.
Right.
People with Alzheimer's disease, they lose their memory because they have accumulation of proteins in their brain called amyloid and tau, but the arteries also degenerate. And we tested Rory, the drug, in animals with Alzheimer's disease, and we found that it was also able to stop the degeneration of those vessels. So we have tested this in many different animal models, and we're very confident that the drug works in these CADASIL models. And we want to keep on going. We want to keep on advancing the drug. This drug has many advantages because it's not like sometimes you hear from researchers, we want to bring this drug to the clinic. And that means the drug has never been in the clinic and they want to take it there. For Rory, it's different. We want to bring it back to the clinic because it was already in the clinic. People already did a phase 1, a phase 2 trial, and we want to bring it back so that now it can help people with CADASIL, help also people with Alzheimer's, help people that have just vascular degeneration in their brains.
This is so amazing to hear. And this is really what makes you so confident about advancing this into clinical trials. But tell me more about this new therapy and, the promising work that you're going to be working with CADASIL plus also Alzheimer's. If you put those two groups of individuals, how many are we talking about that this could literally help in this world?
Oh, now we are talking millions. This drug, I mean, here is the thing. RANX1, the protein RANX1, has not really been targeted as a therapeutic. And over time, in collaboration with a colleague of mine, Dr. Leo Kim, we have found that RANX1 is active in many diseases that affect the blood vessels, including people with diabetes. Now, we have published that. Now I told you about CADASIL, Alzheimer's.
Yeah.
And then we also found out that it can help people that have fibrosis in the lung. This drug can really make a difference for a lot of people with many diseases. And that also kind of like encourages us to bring it back to the clinic, because we know it's not just going to be for CADASIL. I do care about people with CADASIL, but as you advance a drug, you also have to think about like how many people, like you are saying, how many people can we help? Is this going to be worthwhile considering the investment of time and effort? And I think it's tremendously worthwhile. And the drug, something that is unique about it is
Yeah.
that it has this ability to let the vessels kind of like repair themselves. In CADASIL, like I told you before, the vessels kind of like lose some of their cells, like some of them are called the vascular smooth muscle cells or pericytes. And what we found is that when we put the drug, this other cell that is called the microglia and is very inflammatory and triggers this vicious cycles of degeneration, has a lot of RANX1 also. So the moment we put the inhibitor, the microglia goes away, inflammation goes down, and the smooth muscle cells and the pericytes can become healthy again and can stabilize the vessel. So we call this vascular restoration. So when you have a house and it's kind of like falling apart, we're going to turn it down. Or what we're going to do is we're going to repair it. We're going to restore the house. We're going to restore the blood vessels. And this is what the drug achieves.
This is amazing. So, as we're talking about this, let's talk about the timeline and maybe milestones that we're going to be looking at over the next, let's say, 12 to 24 months.
Okay, so we want to put this drug on the fast track. We shouldn't do that with other drugs. We shouldn't put them in any fast track. We really have to be super, super, super careful. For this drug, we can take a different path. It's the path of a repurposed drug. So what we want to do on our timeline, I mean, I care deeply about people with CADASIL. There is a huge need. What we want to do is in the next 18 to 24 months, we have to reformulate the drug. The drug is something that we can produce in a lab, but the drug, as I told you, we want to make it into a pill. That is a process called formulation. I mean, if you have a pill of anything and you break it, there is something like inside. So it's like kind of like added some additives that make it more stable and things like that. So the drug was formulated obviously back in the 90s. But that formulation, the composition, what that formula was made of, is not very well known, and it's also very old. So we think we can do a better job at formulating the drug so that when the person takes the pill, most of the drug gets absorbed and they don't have to take it too often. That's a process of formulation. So, and that takes about 6 months. And then we already had some interactions with the FDA about this drug, and the interaction was very positive. What they said was like, yes, we recognize this was in the clinic, and a lot of the toxicology and safety studies were done, but they are also very old. And some of the standards under which the studies were done way back then are not up to date. We have different standards now. So what the FDA suggested was that we repeated some of those essays. And it's great because, you can never be too, safety is critical. I am a doctor. I was trained as a physician. I care for the safety. The first thing is to do no harm. So we want to take that formulation with the drug and repeat some of those toxicology studies so that we can go back to the FDA and say, hey, we have the drug, the formulation is really good, and look, we repeated all the toxicology tests. These are the results. Would you let us do a clinical trial for CADASIL? So in 18, well, actually, yeah, my goal is 18 months, but if resources are not available, or things don't go as well as we expect, it could go up to 24 months. We want to go back to the FDA and say, hey, would you let us start a clinical trial for CADASIL? Now, but even the trial, maybe we don't have to do a phase 1, because this was already in a phase 2 trial. So maybe we can do it's called a trial 1B, where you kind of enroll some patients, you look at safety, but you are also allowed to start looking at some markers of efficacy. Is this working? Is this helping CADASIL patients? And then hopefully continue so that those patients can receive the drug. So that's kind of the goal. It is ambitious, but we need an ambitious goal right now. For CADASIL people, I meet many of them, and it's something that, it reminds you have it every time you have a migraine, and then it shows you it's really with you when you get a stroke, when you start forgetting things. So we need ambitious goals, and we need everyone to help.
So true. And look at the millions of people that this could help in this world. It's just remarkable. So you've studied how mutated genes damage small blood vessels in the brain. You've developed mouse models to do, better understand the disease. You've identified important blood markers linked to CADASIL. And you're currently working towards this treatment approach and that's aimed at correcting and the underlying genetic problems. But what do you wish more people, clinicians, researchers, and funders would understand about CADASIL and your work?
What is critical right now is, when I first started to work on CADASIL back in 2000 here in the United States,
Yeah.
I was the only one. I was the only one working on CADASIL. So I'm not alone anymore. There are more people there. There are people there are clinicians now that are creating these networks of patients. There are researchers in the United States that have laboratories also dedicated to CADASIL. So, and the patients are more engaged. Before, they were just patients. We will meet in Facebook and organize activities. So it was great to be in that situation, because it allowed me to take a lead. In the United States, I am the person that has published more on CADASIL, which is remarkable. I actually became ultimately a citizen because of my research on CADASIL. I wanted to acknowledge that in the United States, if there is an area of research that is underserved and people or not enough people is working on that, you can actually get a green card on the basis of that. So I want to acknowledge I got my permanent residency because of my research on CADASIL, and then I became a citizen of this great country thanks to that. So it's remarkable. And what I want us to answer your question, what I want us to do now is that I think we need to integrate the efforts more. Now that we have more people, there is not necessarily a lot of coordination. And we need to be very coordinated, and we need more people to participate in these networks of patients. There are people looking for biomarkers to be validated. My laboratory also discovered several biomarkers for CADASIL, but now we need to validate them in people. So I think what is missing right now is more coordination. Some of the efforts right now from clinicians are called clinical trial readiness. So they want to have the community ready for the clinical trial, which means we need biomarkers and we need patients already enrolled, so that when the trial is ready to go, we can invite people and see who qualifies and who doesn't qualify and who can be enrolled on the trial. So I would say, not that when I was by myself, there was no need for coordination. Now that there are more people, we need more collaboration. That has been a problem in CADASIL research, lack of collaboration. There are people in Europe and in other countries, but we need more collaborations. We need more integration, and we need to, like, it takes a village to do this. So we cannot be isolated. That's why I like to talk about the drug. I want to tell people scientists can buy the drug, do their own experiments, do their own validation. It's going to take a village to do this.
Sure. Oh my God, that's just amazing. So are you starting to look to collaborate on those lists? Because I know, in fact, in our rapid fire questions section that we're just going to start right now, that was one of the questions. They were wondering who's doing studies, how can they get in a study?
Well, there are several groups that are doing and are enrolling patients for this clinical trial readiness. That's fantastic. They are looking for biomarkers in the eye, biomarkers in the brain. I just made a presentation recently for the CADASIL Consortium. We have institutions that are creating awareness. I work closely with them. One is Think CADASIL. Think CADASIL has become a supporter of this research. I also work closely with Cure CADASIL. There is going to be an event in June, a patient investigator meeting in June, and I am attending that in person. So I work with all these institutions to create awareness and bring the resources forward that are necessary to get the job done.
That's amazing. So, as I mentioned, I had some members of the CADASIL community send me some questions for you. So, this will be just some rapid fire questions, and we'll see if you can answer some of them. So, first was who will be eligible for clinical trials?
In this case,
Ah,
I think that people that have symptoms will
okay.
be eligible. That's, again, a clinical team will probably be put together to decide that. But for this drug, I think having symptoms will be required. Why? Because we have to be able to do diagnosis. And as I said before, just having a mutation doesn't necessarily give you the CADASIL diagnosis. You kind of have to have some symptoms. So I think symptomatic cases would be eligible. Asymptomatic cases may not be able to enroll at the beginning.
And can you just share four symptoms? Like just off the top of your head, four.
Yeah, so people with CADASIL suffer from migraine, and they can have some memory loss and problems in something that we call executive function that has to do with like how you plan your day and some activities. So those are some of the key symptoms, or maybe you had a stroke before.
Got you.
So
Okay.
it's not like you had a stroke last week, but if you had a history of a stroke, that's symptomatic CADASIL. And those, I think, will be the ones, in my clinical opinion, would be the ones that would be first eligible. Now, of course, if it's found to be safe and effective, then we can go to people that just don't have symptoms.
Okay, wonderful. And another question, will the drug reverse the damage already caused by CADASIL?
I think what we observe shows evidence of that in a way. So we can stop progression of the disease for sure, because I have seen evidence of that. Now, what happens is that the moment that you stop progression, the drug, the arteries and the brain repair themselves. So I don't know, I don't have evidence that the drug is triggering the repair itself, but it's allowing for it to happen.
Right. Okay. And another question, is there a correlation between an electrolyte imbalance and CADASIL episodes triggering a cascade of symptoms such as TIAs or other neurological deficits?
That is a good question. Electrolytes are, you can think about them as like salt. We take salt, and then that salt goes into our arteries, and the levels of that salt or electrolytes have to be regulated between the brain and the vessel. Yes, when you have electrolyte imbalance, that can trigger seizures, that can trigger some of the symptoms of CADASIL. And that's why, but that's also a reflection of like a vessel that is very leaky is prone to have that imbalance. That's why we think that when we have this therapy and the leakage is stopped, then it will benefit the patients.
Right, interesting. Here's another one. Can a concussion early on in life bring on early effects of CADASIL?
Yes, and that is true. I mean, for a concussion in general is not good for the brain, and it can trigger the beginning of a disease like CADASIL or make it worse. I don't think we have had like that will need to be studied. Like we will need to run a study for that to really be absolutely sure. But concussion doesn't help
Right.
with any disease. Like in Alzheimer's is also bad, and I will anticipate based on what I know that's going to be the same for CADASIL.
Okay. And outside of quitting smoking, not drinking alcohol, and having a low sodium diet, can diet really make a difference with individuals with CADASIL?
Yes, on that we have evidence that cardiovascular risk can make CADASIL worse. So a balanced diet, just not being obese, also in combination with the exercise, can really help cardiovascular function. We're talking about the heart, we're talking about the arteries, and those are very susceptible. You can make them worse with a bad diet, but they also respond when you change it.
Oh,
They also respond when you change it. Sometimes people focus too much about appearance, and it's like, oh, what they look, my external appearance. Focus on the appearance of your arteries because those are the ones that will give you like a heart attack or like a stroke. So it's the appearance of the arteries that matter. And it's, oh, I lost, don't look at your waist. I lost like 50 pounds. It's like, but it's not just the waist. It's kind of like look at the waist of the arteries, okay?
absolutely. So true. Okay, so here's another one. We know CADASIL is tied to the mutation in the Notch3, but are there many different variants? And do all of these mutations behave in the same way in the body, or do some lead to more severe disease than others?
There has been some research on, I've been interested in this problem for a long time. The answer is yes. There are hundreds of mutations in NOTCH3 or variations in NOTCH3 that are linked to CADASIL. Let's talk about the more recent data. It's not my work, but I think it's now very validated. They found that, NOTCH3 is kind of big. It's a big receptor. You can think about it. It's like this is a big receptor, and if the mutation is at the beginning of the receptor, as opposed to here in the middle or at the end, then the disease could have like an earlier start and progress more severely. We call that the first five. Notch receptor, Notch3 receptor has like these repeats. Yeah, and because they are sequences that repeat, and the Notch3 has 34 of them. I've been studying this, so I know it to the dot. So the Notch3 has 34 of them. If the mutation is in the first five of these repeats, it could be associated with more severe disease. If it is like after those first five, so it would be like the other 29, I would say. I think I got it right. So then it's like less severe.
Okay.
Now, we think that the therapeutic can help all the patients, regardless of where the mutation is. And the animal models that we have tested have a mutation like here and the other one over here, and it works for both of them. So we have evidence that the therapeutic can work.
Okay, wonderful. Another question about adrenomedulin and PDE5 inhibitors. Do you know anything about a study on those in CADASIL?
I think like that, it is important to look at other targets and do more clinical trials. In CADASIL, I would say that's also fair to say we haven't failed enough. There haven't been enough trials. There had been, maybe two or three that I can name. So in other fields, they have made some progress in therapeutics, but they have failed a lot, and then they have a winner. So I'm not going to speak about those particular drugs. It's not my work. But I would say that if there is some evidence of that, it would be great if trials are done. to really see if they can help patients. Because, like I said, in CADASIL, we haven't done enough trials. We haven't failed enough. And when you fail many, many times, then you get a winner. That's what we need.
Absolutely, absolutely. More people looking for those cures. It's so important. Now, all the literature says that there's about a 50% chance of inheriting a gene, a mutated gene. However, this person writing in said that CADASIL families seem to see that number much higher than 50%. Do you have any ideas on the numbers?
The genetics usually work, but the way they are supposed to, like if a parent has CADASIL and has only one copy of mutant NOTCH3, half of the children will probably get the mutated gene and the other half won't. Now, why don't we see kind of like that even breakdown in some families? That just has to do with like randomness, like serendipity. Let me give you an example. Like you've seen those families. It's the same for having a boy or having a girl. Every person, every couple has a 50% chance. But you have seen those situations where a couple keeps trying for the girl and they only get boys.
Sure.
And it's just the odds. The odds for every child are always the same, but they keep just having girls or the other way around. They keep trying for boys and they have only a friend of mine has 5 girls. And I was like, it's just what it is. But the odds were the same at every iteration. So I think the odds for CADASIL, the situation is sometimes you have parents that have 2 copies of the mutated gene. So those are what we call homozygotes. Homozygote. Homo the same zygote is like they have the 2 copies. So now if a parent has 2 copies, all the children will inherit the disease. All of
Interesting.
them will get it. So the genetics is called what we call Mendelian genetics. Uh,
Sure.
it works that way. But I think some people are confused because it should be half. I know a family in Colombia. I think they had like 10 children. 9 of them got no, actually 8 of them got the mutated gene and 2 didn't. It should
Wow.
have been 5 and 5, but it was 8 and 2.
Right. So really interesting. That's just always how it is with odds.
Random.
It's random. When would you want patients with CADASIL to start taking this medicine? Would it be, and of course, if they're genetically tested, would you want them taking it right when they're born, in their teenage years, later on in life? What would be the time to start?
I believe in prevention. I think it would be great to like start a low dose early in life. I don't see a need for people necessarily um, to take it as children unless they have symptoms. CADASIL manifests itself as an adult condition. I think probably at the time that you start seeing some changes in the MRI, that could happen as early as in their 20s or 30s, and maybe it can also help with migraine. I will anticipate it might. So at the beginning, it could be like symptomatic, people in their 30s or 40s, but if it's found to be safe and effective in people with CADASIL, then we can go earlier and earlier. But I'm a believer in prevention therapy. And again, prevention therapy can be done. The drugs just have to be like super safe.
Sure.
That is done in other conditions. They do that we call that prophylaxis. And they do
Yes.
that for like HIV. The drugs are very safe. People take them every
Right. Absolutely. Okay, so has there been any success for patients with CADASIL with stem cell treatment?
day. No.
Okay, that was another. What is the youngest person that you've known to have CADASIL, and also about the oldest? So when have you?
It really depends there are, I, of people that I know of is for the academic literature. Usually when there are these extremes, a paper comes out. There are small children that have, but again, what is having CADASIL? I remember some parents that had CADASIL and they will bring their little kids, and the girl was like 3, and complain about headaches. Where
Mm,
is it coming from? It's probably CADASIL, right? So I
right.
would say that person is probably not going to get a stroke, or that kid is not going to get a stroke. I consider that symptomatic CADASIL. Now, all this, I also remember like a patient, we went to his farm. He was almost 80 and he didn't want to come for like studies because he was like, I don't have it. I'm running the farm. I wake up at 5 a.m., work the field. What are you talking about a stroke? As it turns out, he had CADASIL.
Oh,
He
and he was
wasn't
his
very, he
80,
wasn't, yeah, he was very, but
very
he wasn't,
active.
yeah, he was very active and symptom. Unfortunately, it's like shortly after we told him he got the first stroke. So I
Oh,
always blame myself for that. But, he was just fine. He didn't know about it. But, it's just, it's one of those things that, yeah, people could be really old and get it.
sure. Okay, so now back to the drug. Now, if you're, we're fast forwarding and people are starting to take this drug and it's helping the stop the degeneration of the blood vessels in the walls, would you have to continue this treatment um, throughout the rest of your life? And what would happen if you stopped taking it? How quickly would that degeneration occur again?
That is a great question. I would say, like I mentioned before, RANX1 is a transcription factor. It tells other genes what to do. Usually, when you have that type of protein, you don't necessarily have to block it or inhibit it all the time. Let me give you an example. Steroids are also transcription factors. I mean, the steroids are drugs that target transcription factors. And as many people know, you don't have to take those drugs, those steroids all the time. You do like short cycles of steroids, like 5 days, and then you are good for a long time. Or you do like one shot and you're good for a long time. So maybe the trial has to investigate that. Where the therapy that we did in the animal models was short. It was in animals with established pathology, and we treated them for a month. And the recovery was very substantial. Now,
Interesting.
we didn't test what happens if I stop the therapy. That can be done in the animal models or that can be done in people. But in principle, I will anticipate that maybe we can do a short cycle, stop the drug, because who wants to take a pill every day? And then maybe after a certain period, you take another cycle. That sometimes is done also in patients that have MS. They do like some cycles of therapy and then they are in remission and then they are fine.
Right.
It would be a dream come true if that happens. Yeah.
Right. Oh, that's fantastic. That's a lot of hope right there. Okay, how expensive is this drug going to be? That was one of the one of the questions.
Well, it's gonna be cheaper than what we call biologics. Sometimes, so there are these really expensive drugs that sometimes they make it to the news. They are like antibodies, or they have antisense oligonucleotides, or even messenger RNA. So those are called biologics. And like I said, those drugs are usually more difficult and expensive to make and more difficult to administer. Now, small molecules are just a pill. They can be mass produced. So I don't know how much it will cost, but I can tell you it's going to be like a lot cheaper than, let's say, an antibody infusion. How cheaper could they be? They could be 5 to 10 times cheaper because you can make like kilos of it. You can make like, many kilograms of that. They could be mass produced. And then also you don't need like a special setup to administer.
Right.
Uh, you know, not at the point of setting up a price for that, but I can tell you it's going to be 5 to 10 times cheaper that if what I had to offer was the antibody that I was working on before.
Oh, that's great news. And so for a family that's just received a CADASIL diagnosis, what would you want them to know about the state of the field today versus 5 years ago?
I think we are in a lot better shape. Just because before we didn't even have these like consortiums of patients. 5 years ago, we didn't have Think CADASIL. We had Cure CADASIL. So now there are more organizations coordinating and bringing awareness and doing fundraising for CADASIL. So and 5 years ago, I didn't know either that this drug could help people with CADASIL. So now we have another option that brings hope. I think we are in a lot better shape. And, I think it's for someone that has been working for so long on this, I have lost a lot of my patients. But these people that were my patients way back then, they are not with us anymore, and that's very sad. But I can say that for their children, it's probably true that we're gonna have a therapy. So it's just what it is. I think I wish it had done been faster, but I think for their children, for these people that the children of the people I met when I was a med student, we can definitely do something for them.
The future generations. And so, as we kind of look in that vein, have there been patients or families that really have shaped the way that you look at this work? I know you mentioned families back in your hometown.
Well, I think those families made a huge difference. I have been very inspired since I've been here now for like 26 years in the United States. So I got to know uh, some of the CADASIL people with CADASIL here in the United States. I think their energy is inspiring. How they organize their efforts towards fundraising is remarkable. They do make a difference every time they call, every time they participate in research, every time they make a donation. Some of them, some people I I met via Facebook many years ago. They committed to make small donations every month, and they had been doing it for years, and
Wow.
they never miss a donation. And I get a report every month. Isn't that inspiring? Some people that show that commitment. Just recently, a family I met at an event made a pledge. It was an amazing gesture because they made a pledge for supporting this research and it's kind of like a match. It works like a match. Let's say if we can give $125,000, and if you can match it, which means at the end, I will end up with like $250,000. And that is remarkable because it encourages everyone to feel like, I'm not just a patient with CADASIL. I am being active here and I'm making a difference. And that is empowering. This community has a lot of power. They have they bring power with their prayers. I'm a believer myself, and I think that gives that helps. They bring power every time they participate in research, and right now, doing philanthropy and making donations is also more important than ever. Just because now there is a rebalancing, the National Institutes of Health has different priorities now. So people now have the power to say, hey, I want to support CADASIL research. This is important for me. And they can do it. And we just had this family come forward and be like, hey, I met them at an event and then they came back. It was a beautiful story. They got a call at the front desk. It's like somebody called and they want to make a donation for CADASIL. And, that led to this pledge that works as a multiplier and can accelerate the development of this drug. And this is important for people because it helps the research materially, it helps advance the work, but also it helps them because they feel that they are part of the solution.
Yeah. And isn't that such a beautiful gift to the world, really? Because we're talking about patients with CADASIL, we're talking about people with early onset dementia, Alzheimer's. This is going to help so many people. And so I think so many people want this to happen today, make this treatment available today. So we really need to bring people from all over this world together so that we can make a positive approach to how you get your work done in the next 12 months, in the next 18 months, in the next 24 months. I love that idea. I'm completely behind that opportunity of that grant challenge. So you have, if you get to another $125,000, There's a matching donor that's going to give another $125,000. That's remarkable. That's amazing. And so I think I'd love to add in, if anybody is listening and they want to learn more about how they can give to help you in your lab develop this, they can reach out to thinkcadasil.org or Melissa Paul, and I'll just give her a telephone number, 617-686-1440. And every donation will go through, what is it, Mass Eye and Ear, and it will
Correct.
get earmarked into you and your research lab, correct?
Yep. Yes, that is the way it works. And I can tell you, these people are putting their wallets where their mouth is, because we already, I mean, the goal is to get 125, and then that gets matched. But we are not at zero. This person already gave us $50,000, and think CADASIL gave us $25,000. So we already have $75,000 in the bank, and we're already using it. I was able to hire one person that joined the lab just this week to work full time on this project. So this is fantastic. I think, there's been a lot of things on the news about like, oh, we need more funding for research, what is happening with the federal government. But guess what? Here there is an opportunity, because people now is not just complaining about that. It's like, oh, now I can make a difference, make a donation towards something that I care about. Then sometimes it helps with taxes. So, and they can actually feel that like they are doing research by supporting it. Not everybody can go to like Harvard and get a PhD. I did that. I have people that started, but how are you part of the solution? And I think that is just fantastic. And this matching fund will specifically fund the formulation step. So
Yeah.
the formulation step, what I told you, that we take the raw drug and we make it into like a pill that people can take. That's paid with those 250,000, and the work started thanks to the people that have donated to Think CADASIL, and thanks to like this amazing donor that made the pledge. And it was also their idea to make it as a match. They know what they are doing. So they were like, no, we're not going to give all this money just like that. We're going to make it like a match because we want you to raise the rest. And then once we have that formulation, we'll start repeating some of that toxicology work that the FDA wants. And for that, we are raising $500,000. So, but we are taking it one step at a time, and the work has begun. And I can tell you this, sometimes in some of my articles, I have acknowledged people by name because they have been tremendous in their fundraising efforts. But like I'm saying, I wouldn't be where I am right now without the support of CADASIL people. The first grant that I got was from the American Heart Association in the United States. And it was kind of like maybe it was gonna get funded, maybe not. It was a very nice grant, and at the time, through Cure CADASIL, they signed a petition and they got signatures, and they got so many people to sign it, telling the American Heart Association that this was important for them. And I ended up getting the grant from the American Heart Association. Imagine it, we have done so many things with people here, and some of them have been, I don't want to name them here because they gave me their permission before, but I don't know if I still have permission to mention their name, but some of the papers have their names because they gave me permission at the time. I don't know. I love the CADASIL community here in the United States, in Colombia, everywhere. I decided to devote my life to CADASIL research for a very simple reason. I just felt that nobody was paying attention. In my research center in Colombia, everyone was working on Alzheimer's. And I was, that's too many people working on Alzheimer's. I want something that is more neglected,
Yeah.
a place where I can make a difference. And I was in med school, but I was young. I was like, oh my God, I was like 21 when I was in med school, I was 21, and I was looking like, what do I do with my life? I want to make a difference, and I felt like I could make a difference in this niche for these people that not a lot of people care about, and I'm still at it, and now I feel like I got it. I feel like I've learned something about CADASIL along the way. I feel like I have tried other drugs and maybe they were not that good as what I have now. So now I just turned 50 recently, and I'm like at the point where I feel like I want to deliver on these promises I made to myself and these promises I made to the CADASIL community. And I really feel like I got it. I feel like I have something here that I feel confident it's going to be safe because it was already tested and found to be safe elsewhere and in other people. And I also have been studying and publishing on this drug for quite a few years. And, in all the models, it always works. It's a very potent drug. So this effort is bringing a lot of fulfillment for my life because that'll be a great day. That'll be a great day when we get to put like a therapy in in someone that has CADASIL, and it gets them to feel better. And very likely they're gonna be like, yeah, but this is not something that a pharmaceutical company I never heard of kind of like whipped out. No, this is something I might have donated in the past, or this is something that Joe, this guy that that has been working on for so long.
Well, everybody in the CADASIL community thanks you for your passion and your dedication to CADASIL. It's been remarkable. And for so many years, you've been getting yourself out there and learning more and developing and creating. And we can see the hope that is there. And it's all because of you. So thank you so much, Dr. Joe. I mean, there's so many people that, call me and text me, and they have so many wonderful things to say about you. I know we're at the end of our day today, so we did cover a lot. If you could share one message with the public based on everything you know about CADASIL, what would it be?
Okay, well, we went through a lot. Like you said, I think the one message will be you're not alone. I think
That's
we
priceless.
have made progress thanks to you. Participate on clinical research. Those invitations that you are getting, even if they don't have a therapeutic, will enable us to do the clinical trials, hopefully very soon. I want you to know that I'm very committed to help you and your families. I think we have a lead for a new therapeutic that I think checks a lot of boxes. It's a drug that has been in people before. It shows a great efficacy in our models. And also, I think that we can bring it really fast to the clinic. Uh, I want you to feel that you can make a difference when you participate in research. I want you to feel that you can make a difference with your prayers. I want you to know that you can also make a difference when you donate to research. Uh, Together, we can end CADASIL, which is what we all want. I made this my life mission, and I want to see it through. So thank you so much. CADASIL has given me a lot. The CADASIL community has been great. You gave my life a purpose, and I want to fulfill the purpose of helping CADASIL people.
Oh, thank you so much for those words. And it's so true. You are not alone if you're out there with CADASIL or your family member has CADASIL. There's so many people here to support you. I love what you're doing, Dr. Joe. So thank you so much for joining us today and sharing your expertise. We'll be sure to have you back to follow up as we come closer to the trials too. Oh,
Please, I'm on a timeline. And now I committed to a timeline. So yeah, keep me on my toes. And thank you so much
definitely.
for the invitation. This was awesome.
Yeah, and I'll be sure to add resources and also links to donate in the notes for our listeners. And in addition, we want to just give a big thank you to Think CADASIL for all that they're doing to educate and empower the public about CADASIL and fundraising opportunities to find a cure and get the treatments out to everybody in this world. So as we close today, I would have to say that one of the most powerful messages we can leave with is this: there's hope. And that's it for today. We'll be back for another episode to increase public awareness about topics faced by people in their daily lives, whether traveling around the corner or around the world. Be sure to visit us at globalsecureresources.com for more information about our community awareness and prevention programs. And don't forget to hit that follow button. We'll see you again.